A plane goes down somewhere over the ocean. Everything is gone. The fuselage shattered. The electronics melted. 10,000 pieces scattered across miles of seafloor. By every law of physics, the story of what happened in those final minutes should be lost forever. And yet, again and again, investigators pull a single scorched object from the wreckage, plug it in, and suddenly they can hear the pilots' voices and watch the entire flight replay, second by second, as if they were sitting in the cockpit themselves. It survived fire that melts steel. It survived an impact that pulverized everything around it. It survived the crushing black depths of the ocean. People call it the black box, and it might be the most over-engineered, quietly heroic object on any aircraft you've ever flown on.
Today we're going to take it apart and understand exactly how it works, what it records, how it survives things that destroy everything else, and why this one stubborn box has done more to make flying safe than almost anything else in history. And we'll start with the biggest lie in its name. Because here's the first surprise. The black box is not black. It's bright orange, vivid, screaming, safety cone orange, often wrapped in reflective tape. And that's completely deliberate. When a plane goes down, that box might be lying in dark water, buried in mud, or hidden in a field of twisted debris. And investigators need to spot it fast. The last color you'd want is black. So why on earth is it called a black box?
Nobody is entirely certain, but the most popular explanation traces back to World War II, when sensitive electronic equipment in aircraft was sealed inside plain black metal casings, and the nickname black box became slang for any mysterious sealed device that did clever things inside. The name stuck even after the device turned orange decades later. So the very first thing to know about the black box is that its two most famous traits, being black and being a single box, are both wrong. It's orange, and it's not one box. That's right, what people call the black box is actually two separate devices, each doing a completely different job. The first is the Flight Data Recorder, or FDR. Think of this as the plane's body. It records what the aircraft was physically doing. The second is the Cockpit Voice Recorder, or CVR. Think of this as the plane's mind. It records what was happening among the people flying it. Put the two together, and investigators get something extraordinary. A near-complete reconstruction of both the machine and the humans in the final moments before a disaster. One tells you what the plane did. The other tells you why. Let's look at each, because what they capture is genuinely staggering. Start with the Flight Data Recorder. In the early days, these tracked just a handful of basic measurements, but a modern FDR is a monster of detail. It continuously logs dozens, and in advanced systems, hundreds of separate parameters about the aircraft. At minimum, things like altitude, airspeed, heading, and vertical acceleration, but extending out to engine power settings, the position of every control surface, the angle of the wing flaps, the flow of fuel, autopilot status, and on and on. Some of these readings are sampled many times every single second.
The result is so detailed that investigators can feed it into a computer and build a complete three-dimensional animation of the flight. A perfect digital replay of exactly how the plane moved, tilted, climbed, and turned through the air, right up to the final instant. They can see whether a pilot pulled too hard on the controls, whether an engine lost power, whether the plane stalled. It is, in effect, a flawless mechanical witness that never forgets and never lies. Then there's the Cockpit Voice Recorder, and this one is more intimate. It captures the audio environment of the cockpit, the conversations between the pilots, their radio calls to air traffic control, and crucially, the ambient sounds. And those sounds tell stories. The hum of the engines, alarm tones, warning horns, the clicks and clunks of switches, even the specific noises of the airframe, all of it gets recorded across multiple separate audio channels, so investigators can later untangle who said what and which sound came from where. A trained investigator can listen to that audio and extract astonishing detail. The moment an alarm sounded, the pilot's tone of voice, the exact second something went wrong. Sometimes, when every other clue is gone, the voice recorder is the only thing that can explain why a flight ended the way it did. the last testimony from a cockpit where there's no one left to ask. Now here's a feature that surprises people. Neither recorder keeps everything forever. They run on a continuous loop, constantly recording over their own oldest data. By international standards, the data recorder keeps at least the last 25 hours of flight information, while the voice recorder traditionally preserved the last 2 hours of cockpit audio. Older material is simply overwritten. This is partly a practical choice, and partly a deliberate one, balancing the needs of investigators against the privacy of crews who don't want every word they've ever said in a cockpit kept on file. What matters is that the box always holds the part that counts the most, the final stretch leading up to an incident. We'll come back to that 2-hour limit later, because it has recently become the center of a real fight. But all of this raises the real question, the one that makes the black box almost mythical. How does a device survive a plane crash when a crash is precisely the kind of event that destroys absolutely everything else? The answer is one of the great feats of engineering, and it comes down to a small, fiercely protected heart inside the box, called the Crash Survivable Memory Unit. This is the only part that truly matters. The outer chassis, the wiring, the circuit boards that handle recording during normal flight, all of that can be mangled beyond recognition. But the memory unit, the part that actually holds the data, is built like a vault inside a vault inside a vault. At its center sit the memory chips, where the data lives. Around them is a thin layer of aluminum. Around that is a thick layer of special high-temperature insulation designed to hold back searing heat. And around all of it is a heavy outer shell of stainless steel or titanium, two of the toughest metals we have. Layer upon layer, each one guarding against a different way the box could die. And the testing these things go through to earn their place on an aircraft is almost absurd. To be certified, the memory unit has to survive a battery of deliberately brutal tortures. It's fired from an air cannon or slammed to create an impact of around 3,400 times the force of gravity, a shock thousands of times more violent than anything you'd ever feel. It's placed in a furnace and roasted at over 1,000 degrees Celsius, hot enough to melt aluminum and glass, for a full hour, and then exposed to lower heat for hours more. It's put under a static, crushing force of thousands of pounds bearing down on it. It's pierced with a sharp spike dropped from height, and then submerged deep in water, pressure tested to survive at the bottom of the ocean, thousands of meters down, for a long time without leaking. Engineers essentially try every method they can think of to destroy this thing. Fire, impact, crushing, drowning, puncture, and it has to come through all of it with the data perfectly intact. The black box isn't just sturdy. It's built to be one of the most indestructible objects humans manufacture for everyday use. There's a grim poetry to it. We surround the most fragile thing, the truth, stored as delicate electronic data, with the toughest shell we know how to build. There's also a clever bit of placement strategy at work. The black box is almost always installed in the tail of the aircraft. There's a cold but brilliant logic to this. In most crashes, the front of the plane hits first and absorbs the worst of the impact, acting as a crumple zone, while the tail tends to be the last part to arrive and often suffers the least damage. So engineers put the most precious object in the spot statistically most likely to survive. Even the device's survival odds are engineered, and to keep it powered when the aircraft's systems fail, the recorder carries its own independent battery, so it can keep running and signaling even when the rest of the plane has gone completely dead. But surviving the crash is only half the battle, because a perfectly intact black box is useless if no one can find it. And when a plane goes down over open ocean, finding a box the size of a shoebox on a vast, dark seafloor is a staggering challenge. So the recorder carries one more tool, an underwater locator beacon. The moment it's submerged in water, the beacon activates automatically and begins sending out an ultrasonic ping roughly once every second, like a lighthouse calling out into the dark. Search teams with the right equipment can detect that ping from a considerable distance and home in on it. But there's a catch, and it's a serious one. That beacon runs on a battery that typically lasts only about 30 days. After that, it falls silent, and the ocean is enormous.
This is exactly the nightmare that played out with Malaysia Airlines Flight 370, which vanished on March 8, 2014, on a flight from Kuala Lumpur to Beijing.
Despite one of the largest and most expensive searches in history, scouring vast stretches of the Indian Ocean, the recorders were never recovered. The 30-day window closed long before searchers could pinpoint a location, leaving one of aviation's deepest mysteries unsolved to this day. It exposed a hard truth. The data can be perfectly preserved and still be lost simply because we can't find the box. When a black box is recovered, though, what happens next is a delicate art. The box doesn't just get plugged into a laptop. If it's been underwater, investigators keep it submerged in clean water during transport, because letting salt water dry out could let corrosive crystals form and damage the memory inside. At a specialized lab, and only a handful of countries have the expertise to do this, technicians carefully peel away the battered outer layers, rinse the memory unit with distilled water, extract the precious memory chips, and connect them to a replica system to read the data out without harming it. From those chips, the entire flight comes back to life. The animation of the plane's every movement, the voices from the cockpit, the full story. Months of investigation can hinge on the contents of one small, fire-blackened unit. And it's worth pausing on just how powerful that recovered data can be, because there's a striking example of it. On November 12, 2001, American Airlines Flight 587 went down shortly after taking off from New York. And because it happened just 2 months after the September 11th attacks in the same city, the immediate fear gripping the public was that this might be another deliberate attack. The implications of that were enormous. But when investigators pulled the data from the flight recorder, the numbers told a completely different and far more technical story. The recorder showed that the first officer had made a series of aggressive rudder inputs after hitting turbulence from a jet ahead, and the stress of those rapid movements caused the aircraft's vertical stabilizer, the tall fin on the tail, to break away. It wasn't an attack at all. That single box didn't just explain what happened. It calmed a frightened, jittery public, steered an entire investigation away from the wrong conclusion, and led directly to changes in how pilots are trained to use the rudder. That's the power of having a witness that deals only in cold, recorded fact. It can shut down a panic and replace fear with truth. And this is the part that elevates the black box from a clever gadget to something genuinely profound. Almost everything you take for granted about how safe modern flying is, and it is extraordinarily safe, was paid for in lessons read out of these recorders. After an accident, investigators use the data to pinpoint exactly what went wrong. And then that knowledge gets turned into action. A design flaw gets fixed across an entire fleet. A confusing cockpit warning gets redesigned. A training procedure gets rewritten. A new safety rule gets written into law. Every recorder that gives up its secrets makes the next flight safer. The whole system works backward from disaster toward prevention, and the black box is the bridge that makes it possible. The device was actually born from this exact idea. In the early 1950s, a young Australian scientist named David Warren was helping investigate a series of mysterious crashes of the de Havilland Comet, the world's first commercial jet airliner, which kept breaking apart in flight in 1953 and 1954 for reasons no one could explain. There were no witnesses and no clues. And Warren had a simple but revolutionary thought. What if the plane could record its own final moments? What if it could testify for itself? His early designs were dismissed and rejected for years. Some aviation officials saw no need for it at all, before the world finally understood what he'd given it, a way for every disaster to teach a lesson that might protect the people on the next flight. But for all its genius, the black box, as we've described it, is, at its core, a century-old idea. Wait for catastrophe, then go dig the truth out of the wreckage. And that approach has a glaring weakness, the one Flight 370 exposed for the entire world to see. What if you can't find the wreckage at all? This is why the future of the black box is now the subject of an intense, fascinating competition. A race to make sure we never lose the data again. The first big idea is streaming.
Instead of locking the data inside a box and hoping to recover it, why not beam it off the plane in real time, up to satellites and down to the ground, so a copy exists safely no matter what happens to the aircraft? In a world like that, there would be no desperate underwater search at all. The data would already be sitting on a server, waiting. Manufacturers have already developed versions of this black box in the sky. The second idea is even more dramatic: the ejectable or deployable recorder. This is a black box designed to automatically blast free of the aircraft at the moment of a crash. And because it's built to float, it pops up to the surface of the ocean and transmits its location, instead of sinking to the bottom where it might never be found. This technology already exists. It's long been used on military aircraft, and one major manufacturer has begun installing deployable recorders on its newest passenger jets. And then there's the most controversial frontier of all: cameras. For years, investigators have pushed to add cockpit image recorders, essentially a video black box, arguing that actually seeing what the pilots and instruments were doing would solve cases that audio and data alone can't crack. It sounds obviously useful, but it has run into fierce resistance, and the reason opens a genuine ethical debate. Pilots' groups argue that being filmed for every second of every flight is a profound invasion of privacy, that a cockpit is a workplace, and nobody wants a camera recording their face through hours of routine personal conversation, footage that could potentially leak or be misused. This same tension is behind a recent, real fight over simply extending the voice recorder from 2 hours to 25. On one side, investigators argue that a mere 2 hours often isn't enough, that crucial events earlier in a long flight get overwritten and lost. On the other side, pilots worry about being recorded, in voice and potentially on camera, for an entire working day. It's a genuine clash between two good things: the relentless pursuit of safety and the basic human right to a little privacy at work. And how we resolve it will shape what the black box becomes next. So the next time you're sitting on a plane, somewhere behind you, back in the tail, there's a bright orange box quietly listening and remembering, recording everything, asking nothing. It will almost certainly never be needed. It will most likely fly its entire life in silence and be retired having never told its story to anyone. But it is built, obsessively, almost lovingly, for the worst day imaginable, the one that probably will never come. It can take fire that melts metal. It can take an impact that flattens everything around it. It can sit at the bottom of the sea and wait. It exists for a single purpose: to make sure that even in the very worst case, when everything else is lost, the truth survives. Because every honest answer that box gives is a lesson, and every lesson it teaches is, somewhere down the line, a flight that lands safely instead. That orange box is, in the end, a promise that we will always choose to learn from the worst days, so that there are fewer of them to come.